Hello everyone, welcome to my channel Learning from Data. Today I'm going to show you the Python implementations of the notebook that I have recently shared with you in my Medium article. The title is Outlier Detection Part 1. I am mostly working on Jupyter Notebook for Python. I have recently created a new playlist section in my YouTube channel which is called Code Walkthrough, and I'm going to populate this section with all the code implementation videos here. I have just started this playlist, so this will be the very first video that I'm going to show you today. Well, let's start with it. In this outlier detection procedures, I am going to show you the 4 different methods. The first one is IQR, that is interquartile range. The second one is standard deviation. The third one is Zscore, and the fourth one is the modified Zscore. In this Python Jupyter notebook, first of all, we need to import all these necessary libraries. The data that I used here is the Airbnb data from Kaggle, which has typically some of the listings and reviews, as well as the dates of those apartments or housings, all the different rental properties information over there. But I'm going to use only the listing.csv here. I have created another dataset, which is normal-data.xlsx. This is a normal distribution dataset that I created just for comparison. If you want to compare the data from this listing.csv with whatever the output coming from the normal data, you can create your own normal distribution data and import here and then compare with our listing dataset. Let's see what is there inside the listing.csv file. Here we have ID column, we have the listing URL and a bunch of other columns over here related to all the rental properties. We are interested in a certain numerical column. Over here we have the price listed here, and there are a bunch of other information associated with all the rental properties, but let's say we want to deep dive inside this price column. You can see that for all the price values over here, there is a dollar sign in front of it. Let's manipulate this data and see how we can how much we can get insight from this price data. First of all, there are some null values over there, and even if there is no null values, it's good to have this filling command which fills all the null values by mean. Let's do that one. Let's first read this. Let's fill the null values, and then there's a function to remove the dollar sign, as I showed you that we cannot process the data if there is a string or any sign. We need to convert the data into pure numerical value. Let's implement this function. Okay, then here I'm doing the box plot of this price column. Let's implement this one. Here you can see that there are different categories, and over here you can see the house and apartments have majority of the outliers. Over here you can see that these points are way outside the typical value for apartments. For the remaining categories, we have not that much outlier, but for the first two, which are house and apartments, have the majority of the outliers. Then we can select only the apartment property type and see how the variation is there. Let's do this one, apartment, and see all the apartments have 2612 rows, and it has this data. In this next section, I'm going to implement IQR procedure, which is interquartile method. First of all, I need to get the Q1 and then get the Q3, which is the first quartile and the third quartile, and get the IQR value from Q3 minus Q1, and implement the algorithm, which is anything above Q1 minus Q3 plus 1.5 times IQR, and anything below Q1 minus 1.5 times IQR are considered outliers. So from this statement, I am effectively removing all those outliers. So these are my boundaries, upper limit and lower limit. So all the outliers are removed when this command is executed. Well, once those outliers are removed, we can do the box plot from the remaining data. Let's do that one. So this is the box plot for all the apartments after the outliers are removed. Over here you can see for apartments you have a bunch of outliers over here. If you go through my box plot tutorial, you can see that this is the maximum limit, this bar over here, and anything above that one are considered outliers. And even after removing all those outliers based on our limit, we can still see that there is one outlier over here. This limit is not same as before, this max limit, because our data's majority of our data of the outliers are removed, so this max limit is now redefined. Still we can see one outlier over here, but the majority of those outliers are already removed based on our condition. To get the statistics of this box plot, we can implement this box plot underscore stats, and we can see that this is the flyers. That means the outlier value, that is 417, which is this value over here. And some other data are over here as well. IQR, upper whisker, lower whisker, the Q1, median, and Q3. All the data are here. And there is, okay, so stat is not defined. Okay, over here. So the length from stat, and I'm going to take the flyers only from this list. So the length is 1. That means there is only one outlier. In the next section, I am going to implement the same IQR procedure with a multiplier of 1.7. If you have already gone through my video, you will understand that this multiplier value of 1.7 corresponds to 3 sigma value. But over here we added 1.5 as a multiplier, which basically corresponds to 2.7-ish sigma. That means anything above min plus 2.7 sigma can be considered as an outlier. So this point over here is basically above mean plus 2.7 times sigma, not 3 sigma. If we want to implement 3 sigma rule, then we need to put the IQR multiplier as 1.7, not 1.5. Let's do this change in the same dataset and see if there is anything change in the result. We use the same dataset, we use the same same quartiles and IQR procedure, and only change is over here, the multiplier is 1.7 now. Let's do the box plot. Now we can see that there are some outliers. Obviously there is more than one, because we have changed the multiplier value from 1.5 to 1.7. Now if we look at the statistics, you can see there are a bunch of outliers over here. And how many are there? That total 16. Previously there is only one, but now when we change the multiply to 1.7, there are 16 outliers. Now the question is, why do we have more outliers in case of IQR multiplier of 1.7, but we have less number of outlier over here when you used IQR multiplier of 1.5? Let's expand this box plot so that it will be clearer. Okay, obviously over here there are more than one outliers. We have counted it. There are 16 outliers over here. The answer is, when we used 1.7 as the IQR multiplier, we are basically widening our upper and lower limit. By doing that, we are incorporating more and more data points inside that limit. Therefore, after executing this procedure, that is IQR procedure, we still have more data points inside this limit compared to this one. Since we have more data points within that limit, because we have widened the limit, when we do the box plot, we can see that these values are considered as an outlier based on the new box plot limit over here. So this limit is now redefined, and these points which are still there inside the data frame are outliers. That's the reason. The next outlier detection procedure is very much similar to the IQR implementation. This procedure is sigma method. We can use 2 sigma or 3 sigma or whatever sigma you think is capable of detecting outliers. You can use that one, but the industry practice is to use 3 sigma to catch the outliers mostly. When I said 3 sigma, that means it is mean plus 3 sigma and mean minus 3 sigma. So those are the upper and lower limits respectively. So let's execute this one. We have 3 standard deviation here. We have the value mean plus 3 sigma, that is the upper limit. And since we have removed all those values which are above mean plus 3 sigma and which are below mean minus 3 sigma, we can execute this one to see the box plot and the stat and the number of outliers. You can see that when we implement the mean plus 2 sigma and mean minus 2 sigma, we have 20 outliers. So these are the outlier values. Let's change it to 3 sigma. Over here, run this one, and we have this box plot. Now we have this number of outliers. Let's see the stat and the number. Now we have 57 outliers. There are more compared to 2 sigma. So the explanation is same, since we have widened our limit when we use 3 sigma compared to 2 sigma. We are incorporating more number of data points, and therefore when the final box plot is plotted, it will show up with more outliers. The next one is Zscore procedure. Zscore is basically calculated from the mean value and the standard deviation. If you don't know how Zscore is calculated, you can go through my Medium article and we'll have some understanding how this Zscore can be used as outlier detection procedure. Let's say we want to implement the same, we want to use the same column, that is the price column. This is the price in the data frame, and we have converted this all the price values to its corresponding Z-score. Let's execute this one, and let's plot the Z-score distribution. The beauty of Z-score is whatever your data is, since the Z-score is calculated from mean, you are basically subtracting the mean from each and every data point and dividing it by the standard deviation. Therefore, when you do the distribution of the Z-score, it's always the mean is always at 0 and the standard deviation is always 1. From this distribution, you can see that there are lots of points lying over here, so it's a very much right skewed distribution, and these points can be considered as potential outliers. The usual practice is to consider the upper limit and lower limit at 3 and -3. We can use the absolute value to detect those points. Let's execute that one. So it has detected all those outliers, so these values are above 3. So all these price values, for example this price value is 725, it has a Z-score of 3.5, so this can be considered as an outlier. And we have some other high values, for example this is 24.7, this is a very high Z value, and this is 18.2, also very high. So how many outliers are there? There are 21 based on our given condition, and we can plot the box plot over here. We can see there are still some outliers after the box plot is plotted, and we can see the statistics. There are a bunch of those, and how many are there? There are still 57 outliers. Okay, so we have gone through the Zscore procedure. Let's go jump to modified Zscore. So why do we need modified Zscore instead of Zscore? The reason is sometimes your dataset may have very extreme outlier that has the potential to change the mean value. In those extreme cases, it is better to use modified Z-score instead of mean, because it is calculated from the median absolute deviation. You can go through the Medium article and you can see how this modified Z-score is calculated. Let's run the price column, and you can see the Z-score is calculated from here, and we have now absolute deviation of the price column that is calculated from the Z-score over here. So we have the absolute deviation calculated as the price value minus m. M is the median value. So the absolute deviation is calculated by subtracting the median from each and every data point over here. So this is the absolute deviation, and we need to get the mean of those absolute deviation. Now the modified Z-score, we have got a formula over here, and the reference of this formula is also given inside the Medium article. You can go through that reference. If we calculate this modified Z-score, you can see that these are the values, and the usual practice is to set the limit at 3.5. so anything, since this is absolute value, we can use positive 3.5. Let's run this one. Anything above 3.5 can be considered as an outlier. So these are the outlier data frame, and how many are there? There are total 33. And let's do the box plotting. You can still see there are a bunch of those outliers. Let's see the statistics. These are the values, and how many are there? They're total 20. So we have less number of outliers in this modified Z-score procedure, but if we use the Z-score only, we have about 57 number of outliers. Well, that's it. I will show all the remaining and related Jupyter notebooks in the subsequent videos. Hope to see you over there. Thank you.